Okay, so in this video, I wanted to have a quick review of classes, inheritance, pointers, and dynamic arrays. Okay, so let's get started. Okay, so first of all, I'm going to set up a class, and I'm going to call it shape. And then inside this class, we'll have two sets of members. Okay, we'll have members that are protected, and we'll have members that are public. Okay, so for the protected members, we'll have maybe the name of the shape. I'll tab that over. We'll have the length. We'll have the width. And we'll have another member for the area of the shape. Okay, so these members, they're also called fields of the class, and they're also instance variables. All right, so we'll call them fields. Okay. Then the next things we need to set up under public would be the constructor. And in this case, we'll have a constructor that is parameterless. And in this constructor, we'll initialize these instance variables. All right, so we can initialize, first of all, the name. We'll initialize it to something simple like shape. And then we'll initialize the other fields, length, width, and area. And you can do this two ways. You can do it like this. You can do it like that. Or if you don't like typing too much, or if you want it all on one line, you can do it like this instead. And then you can set them all equal to 0 on one line. Okay. This function here, this method, is known as the constructor. It constructs the object. And then there's also the destructor. I think I misspelled that. The destructor. And that's written almost the same as a constructor, except you have to use the tilde, which is this squiggly line thing here. And then whenever the program finishes running, the destructor is called to destroy the object. Right? And we can actually see it in action if we put maybe a statement in the destructor, something like shape is now destroyed. Okay, so now that we have our constructor and destructor, then the next thing we'll do is we'll do some get and set operators. For this example, we'll do a set and get just for the name of the shape. Okay, so for the set, the return type is void. We'll call it set name, and we'll need a parameter. The parameter will be a string, and we'll name it name. Okay. So then this operator, its job is to set the name, which is the instance variable of the class, to set it to whatever is being used as an argument for the method or for the operation. So we would write something like name equals name. Problem here though is this method doesn't know on this parameter here which name am I referring to, right? Because I have two names. I have the instance variable called name, and I have the parameter named name, right? So it's ambiguous, right? To fix that, we can use the this pointer, right? So now we know what we're referring to. We're referring to this, the instance variable name, which is this guy here, and we're going to assign it the value from the parameter, which is this one, right? So you can do it this way. A lot of people, what they do instead, well, there's actually two things you can do. You can change the name of the parameter. You can just do n instead, and then that way there's no confusion, right? So name now refers to the instance variable name or to the field, and this n refers to the parameter, right? But if this isn't descriptive enough for you, then the other option you have is using an underscore. Right? You could do it that way as well. So three different ways of doing it, but either one you choose is fine. Okay, so then now with that we have our set function. Next thing we'll need is the get function for the name. So the return time for the get is going to be string, and we're going to call it get name, no parameters. And the job of this function is to return the value from the field or from the instance variable. Okay, so then now let's create another function. We'll call it void get info. Okay, and then this method, what we'll want to do with it is we want to prompt the user to give us the information for the length and for the width of the shape. Right, so let's prompt the user. So cout, and then we'll ask him to enter the length. Okay, and then we'll cin to the length. Actually, maybe a better name for this function might be setInfo instead, because we're trying to set the values for the instance variables. So we'll call it setInfo instead. Sorry about that. Okay, and then we'll prompt the user for the width. And then we'll cin the width. Okay, and then the last method will be void display info, and this method will display the values stored in the fields of the class, in the protected fields. So we'll want to display those guys. Okay, so we can do something like cout, and we'll display the first one. So, or maybe name. Something like that. We can copy and paste this. Okay, and then here we'll display the length. The width, and then the area. All right, so we have name, length, width, and finally area. And if you want to, you could do some sort of separator. All right, so let's say we run this method in some sort of for loop. Then we'll want to separate the values. So we can do like a divider. Okay, so let me zoom out a little bit. So you can see our entire class here, shape. Here are the fields, and here are the public members of this class. Now shape is going to be the base class, since we're also going to go over inheritance. So this will be the base class. And then we're going to do a derived class that's derived from shape, and we'll call that class rectangle. And rectangle will inherit not only the public methods, but it'll also have accessibility to all the protected members as well. So let me go ahead and show you that. Okay, so let's work on our derived class. So here, this will be class. We'll call it rectangle. Okay, so this is the derived class, and then we separate excuse me, we separate the base class with a colon. Then we specify the access, so it's public, and then the name of the base class, which is shape. And your semicolon. Right, so again, this is the name of the derived class, and it's derived from the base class called shape. Okay, so for this class we'll only have public members. So that would be public. And we'll start off with the constructor. And then here we'll only initialize the name. And we'll call it rectangle. Right, and if you notice, we did not specify, or we did not declare a name field in the rectangle class. Name was given to us, it was inherited from shape. Right? It came from here instead. And we have access to these fields because they're protected. right? Anything that's protected or public is accessible to a class that's derived from the base class, right? But if I try to access these members in another class that's not derived from shape, then we would not be able to access any of this information, right? So that's why they're protected. Okay, so now we have the constructor. Now we need the destructor. And here we'll see out as well. See out. Now destroyed. And then we'll see these in action once we actually compile the program. Okay, so the only thing left for us to do is to declare a method or a function to calculate the area of the rectangle. All right, so we can call it, or the return type is void. We can call it calculate area. And the job of this function will be just to set the area, which is going to be the length times the width. Okay, so without inheritance, we would have had to define length and width and area all over again, right? But since those are given to us by shape, we don't need to declare them again, right? They're already inherited. So that means we can derive other classes from shape, right? So let's say I get this here, I copy it, paste that there, and instead of a rectangle now I want a triangle. Right, so I change this to triangle, and then I'll change the constructors and the destructor. The triangle is now destroyed. The only difference would be this calculate area. Right, to calculate the area of a triangle, it's not necessarily length times width. It's length times width divided by 2. Right, so we can just do that here. See, and I just created a whole other class, and I only needed to change a couple of things. Okay, so let's go ahead and test out our new classes here. So in our main, let's create a rectangle class. Rectangle. And we'll call it R. And we'll call the constructor. Okay. And then we can also create a triangle now. We'll call that T equals triangle. And then now we can set the information for it. So then we have access to all the different methods. So we'll want set info for the rectangle. Then we'll want set info for the triangle. And then we can do something like cout rectangle. And then we can display the information for this object. Right, so we can just do r.displayInfo. And then we can do the same thing for the triangle. Okay, so the only thing with this is if we call these two methods, since we didn't actually use the calculate area method for either shape, then when displayInfo is called, then area will end up being 0. Alright, so maybe what we could do is here under R, we can do calculate area. And then here we'll also calculate the area for the triangle. Alright, so that way once we display info, we'll actually get some values for the area. Alright, so let's try this out. I'm going to do Control F5. Alright, so it wants me to enter the length. The length for this object is for the rectangle, because that's what we're starting out with. So let's say I do 60 for the length, 40 for the width. Now it's asking me for the information for the triangle. So maybe we can use the same values, 60, 40. Alright, so for the rectangle we have 60 and 40, area is 2,400. And then for the length we have the same, but the area is half. Right? And then here we're called, once we finish using our objects, then the destructors are invoked. First of all, it's invoked for the triangle, then for the shape that it was derived from, and then the same thing for the rectangle, and then for the shape. Okay, so now let's do something a little bit more interesting. I'm going to close this out. I'm going to delete all this. Alright, so let's do the dynamic array. We'll create a dynamic array for the rectangles first. Okay, so to do that, first let's create a pointer that points to a rectangle. So rectangle, and then a pointer with the asterisk, and we'll call it R. The next thing we'll need is a variable to hold the size of the array, so we'll call it int size. And then the next thing, we'll prompt the user and we'll ask him, how many rectangles do you have? Alright, so cout, enter number of rectangles. Actually, no inline. Sorry about that. Alright, and then we'll cin the size. Okay, so then the next thing to do is to reassign the pointer to point to a block of rectangles, rather than in this example here was pointing to only one rectangle. Now we're going to point to a whole block of them, or to an array of them. Alright, so then we would do rectangle and then the size. Okay, so then now that we have our dynamic array, then we can use a for loop to assign values to all of the objects in the array, to assign all the instance variables. So we'll do something like int x0, while x is less than the size, and then x plus plus. Okay, so the first thing we want to do in the for loop is to set the name for all the rectangles. Alright, so we can access each element in the array using the control variable, the x, and then set name. We can call it something like rectangle. And then we'll concatenate the index, or the control variable here, to the name. Alright, so we'll do something like, let's see, x plus 1, because we're starting at 0. So instead of it calling it rectangle 0, rectangle 1, rectangle 2, rectangle 3, we'll start at rectangle 1 instead. So I'll just do x plus 1. Right, and then just to be on the safe side, let's convert this control variable, this index, since it's an integer and we're trying to concatenate it to a string. Let's go ahead and use the toString. The toString operation, so that way we can convert this integer to a string, and then we'll concatenate it or glue it to the name here. Alright, so that'll set the name. So the first one will be rectangle 1, the next one will be rectangle 2, rectangle 3, depending on how many we have. We don't actually know how many we have because this is a dynamic array. Okay, and then we can do maybe some sort of separator. Or divider. Okay. And then now we can call the function to set the information, to set the values of the instance variables. Okay, and then after set info, then I can call the calculate area method. And then maybe one change. Along with the divider, maybe I want to display the name of the rectangle. So I can just do something like, or actually, since it returns a string, I can do cout r dot get name, and I can display the name of the rectangle once it's been set here. Alright, that looks pretty good. Okay, so then once all the values are set, then what I would like to do is to clear out the screen. So we'll do something like system cls, and then I'll do one more for loop so I can actually display the values of the rectangle, including the area. So we'll do something like int x again, x is less than size, and then x plus plus. Okay. Then I'll copy this guy here, put him there, so I can display the name for each rectangle. And then I'll just call the display info method. Okay, and then the last thing you need to do whenever you're using any sort of dynamic array or dynamic data type, you need to delete it when you're done with it. All right, so that'll call the destructor. So we'll delete the array called R when we're done with it, right? So then this for loop here sets the values of the instance variables, and then this for loop here displays the values of the instance variables. And then this will delete the dynamic array. Okay, so let's run this, see what happens. Control F5. So how many rectangles do I want? For this example, I'll do 3. Alright, so rectangle 1, we'll say the length is 60, the width is 80. Rectangle 2, the length is 40, width is 33. And then finally the length for the last rectangle is going to be 90 and the width is 10. Right, so we ended up clearing the screen out. Then the area for the first one is this much, and this one's this much, and then finally 9 times 10, or 90 times 10 is 900. Then we call the delete. Then we delete all the objects in the array. Okay, so we can try this one more time. This time we will do a different size for the array. So maybe we'll just do 2. We'll do 50, 40, 30, 20. Alright, so that looks pretty good. And then we destroyed our objects when we're done with them. And we only had 2 this time.